what I'm trying to talk about today and what we want to address, yes, as far as steel, which is an upcoming industry in an organized manner in India, we do talk about large structures, we talk about high rises, we talk about airports, large storage facilities, PEBs and all of that. There's another market that I think we should also start looking out for is the low rise, high density, the smaller market, where although you may not have a very tall building that will stand up and say that, hey, I'm standing here, but it's a huge market that can be captured if the use of steel is taken down to the grassroots levels. Now, it took us a couple of 100 years to go from the brick and mortar idea or a concept of a house or a building to come into RCC frame structures. It really took a couple of 100 years for India to get there. And now we're talking of fast tracking this into steel, and I think it's possible of looking at steel as a material for your mundane buildings. I was just telling Avnit here in the break is that the next seminar in Bangalore should happen in a steel building, and that's my challenge to him. I said, let's not look at having a conference in a building like this. We should have it in a steel, and let's see if we can work that together. So there is a huge market right in the mundane buildings that we would call, and we are seeing the trickle effect in the last half a decade at least, where you're seeing small commercial buildings, some residential buildings, and some hospitality buildings which are moving the steel way. So I think it's a right step, or a step in the right direction. So today, I'm just going to talk about creative aspects of steel and how we as designers and architects look at it. I'm going to show you small examples of how we've tried to do it, or where the global trends are going. Some of the buildings that I have seen and experienced myself, which have moved me in terms of steel, are this. This is a Kengo Kuma, or a Kuma Kengo. It's a museum in, where is this, Osaka? Yeah, so this is in Osaka, and happened to be here, and it was use of steel in a very different league, a very different methodology, a very different treatment. You look at steel as ISMCs and ISMBs and all that. Here we are, where they are reinventing the way steel can be looked at, perceived, felt, and experienced. And so everything that you see which is not wood here is largely steel, including that roof that you see on top is actually steel plate which has been treated with phosphoric acid to give a very rusty stone finish. I'll come to that. Then there is a light wood of, use of light maple here. Every structural element that you see here is steel. So you have concrete floors, steel structure, and then a light use of veneered maple here and there just to bring a bit of warmth in the space. This is an amazing museum, not great on square footage, but the finesse with which steel has been used, the respectability that steel has been given, and that it has taken the use of steel to a next level. Amazing use of detailing and the finish of the steel, not just the structural aspect of it, but you would love to go and touch the panels here, which I did. I'll show you some more images. So all these vertical panels that you see onto, one second, do you have a pointer here? Oh yeah, all these vertical panels that you see onto this side are galvanized steel panels. The finish of that was amazing. I couldn't get my hands off it. I kept feeling it for a while till a security guard came and asked me what I was doing. So I said, no, I just, enjoying the steel. He didn't probably understand what I meant by that. These panels are again galvanized steel panels which have been used. The finesse with which it finishes in millimeter precision right next to the glass elements. And if you see these lines, if you see these lines and the precision with which the steel has been worked. Now imagine this has been fabricated, conceived, drawn, designed, detailed, fabricated, and obviously installed at site, but with the kind of precision and the kind of respectability, the treatment given to steel was amazing. So it's not just the tonnage that one should always look at in terms of, I'm doing a couple of thousand tons here and a couple of thousand tons there. Steel has another value to it, which is aesthetics, and then there are people willing to throw any kind of money at a particular detail or a particular, if you like, a finish or a treatment to this material, and which is what I found interesting. Where do I point this? Yeah, okay. Yeah, so the same space, although it is steel, takes on a very different meaning under a different light setting, if you like. Some details where is used bamboo, again clad on steel. This entire surface here is steel. This entire surface here is steel. It is not concrete. It is steel treated with phosphoric acid, and all of this is galvanized steel, typical bolted systems. And he has used traditional Japanese architectural form of a sloped roof, very simple structure, but the finesse with which they have finished it is mind-blowing. Some of the details here where you can see the clamping system of, these are those galvanized panels here. There's a nice umbrella holder which is tucked away right behind these panels as you'd enter. And of course, you've seen the Guangzhou Tower, again, another application of steel where you, the fluidity of these elements and the way they have been arranged simply creates an awesome curve. It's a very feminine structure, it's very curvilinear, and the kind of awe that you get standing here and taking a shot like this is awesome, because we were talking about laced steel structures to using digrade. So all of those principles are used here. So this is of course when you're playing with scale. So the first project was about how steel can be used in finesse, and here of course it is to create an architectural statement, but more to do with its application in terms of a structural how do I say deduction, how you deduce your structural forces into these elements and using these elements, and then of course the awe of just the simple geometry that has been achieved. Excellent detailing done in terms of fabrication. Each joint here in this building is unique. There are no two elements which are exactly the same. There are tens of thousands of elements, separate steel elements which had to be profiled, designed, profiled, fabricated and installed, where each element was again different. So the engineering aspect, obviously Arup did this, and obviously they did a fabulous job. So here again, steel is used in a very different expression. This has been a favorite. It's an old structure, everybody knows this, Kansai International Airport by Renzo Piano. Somehow I've been in love with this ever since we were students, and the first time we saw this structure come up and all of that. What I like here is of course how the entire roof form was deduced. I'd love to see a day when I would drive by a lane and see a construction like this happening in Bangalore or some part of India. I don't think that day is too far from here. I think we are quite close to that era where we will have constructions happening like this. It gives me goosebumps every time I see an image like that. Then of course I'll not bore you with the details of things. The spine, as they called it, or the vertebra, or that entire skin or the body that was put up at Kansai. Just two aspects marry here. See, the Guangzhou Tower is more an aesthetical element. It has very less application other than the fact that it has a few occupable floors. There are communication towers on top of it. But an airport has to function well. So the whole idea of bringing aesthetic to that extent, the curves that are coming, aesthetically it's extremely appealing, and you have done maximum functionality. The curve of the roof is designed according to the airflow. So the air conditioned actually throw up air into the roof, and the curve of that roof is designed in such a way that it ensures that the cold air reaches the farthest corners of the airport. So amazing amount of detailing, practicality and all of that brought together, and of course made practical by steel. So here you see not just the aesthetics of it, but also the utilitarian aspect, which they've both tried to marry, and they've done a very good job at Kansai. Some other structures from Japan. This was Kenzo Tange's Olympic Stadium, built in 1964. Amazing structural detailing again and execution. We still haven't reached haven't even taken a few steps in this direction of using steel in this manner. 1964 these guys did it, and they did this in some less than 2 years or something. This was executed in amazing time frame and all that. We have to look at an industry which can produce this in the future. Here's my appeal to you as an architect. There's a cross section of the industry sitting right here. So how do we get from where we are today to a place like this, where this is commonplace? You walk across Tokyo and you see steel across, used in all sorts of ways. How do we get there? What are this one? First, it starts with innovation. Somebody has to have the guts to take up and say that yes, I will try and design this, let's try and make a structure which is uncommon. What happens here is largely this. This is quite an interesting slide. We as architects conceive a junction more like that, and when we go to our structural engineers, the sanctity of that design is still there, but some compromises are made on the way because they said, "Are ye plate fit nahi hoga, sir, E-span no dilla, sir," and all that. So then you make some tweaks, some compromises, and all that, and you come up to an engineered solution, which is that. And then you go to the contractor or the fabricator, who sits there and is like, "Sahab, ye kya hai, sahab, ye nahi ho sakta, sahab, ye," you know, and then it ends up becoming something like that. Now, my appeal to you is, how can we reverse this process? How can we make our fabricators tell us that they want to do something like this? So this is an approach where education by forums like this is very quintessential. The next time I want to see another section of audience with just fabricators, welders sitting here. It makes a big impact, according to me, for the grassroots level people of the industry to be here and to see this and to want to have this change. I think that movement has to happen if you have to see this as really a movement which would change things and not just a publication trying to get some brownie points. So if you're looking at it that way, then I think we should try and reverse this chronology. Again, I'll not bore you with these. On the left-hand side, you see the fantastic detailing where you've got cast joints, you've got pin joints which are fabricated to the T, and then we have on the other side of the line, you have the local fabricators as fabrications as we see it here today. So there is a lot of gap between these two aspects. This line here is not so very fine. How do we break that? That's the idea. Of course, availability, people have spoken about this. If you look at the nature, the grades of steel and the various forms or the shapes of the steels that are available today are fairly limited. We are still in the British Zamana, if you like. Correct me if I'm wrong, there are a few architects here. If you just make a tube which was 25 by 200, every living architect here would use it as a pergola everywhere, all the time. It would replace a very vertical, finny looking tube. You don't get it. You don't get it. You have to use a plate, form it, bend it, and then form this. It's extremely expensive, this one. So there are hexagonal tubes that are available outside in Canada. There is a friend of mine who's working, and the availability of they have a huge array to choose from. And we don't find that here. I hope that the industry changes that soon enough where we have more tools to play with, and we like to do that all the time. This is one structure that we are exploring with steel, if you like. Although it's a very small structure, it was a large step for us. Like people have been saying, the speaker before me, Mr. Guraj, talked about convincing the builders or the client in general to take the step to pay that little higher premium for a building in steel for its advantages. That's difficult. In a small way, we've tried to do it in this, and I'd like to share my experience on this project. Essentially, this is a die-grid system where there are no vertical columns and beams kind of a structure. You have a die-grid system which makes this entire skin of this building acts as an exoskeleton. So essentially all your loads are taken care of by the skin, if you like, skin of these steel pipes. These pipes are just 5 inches thick. My client was sweating the day we de-shuttered the first slab because he's like, "Are you sure this is going to hold up, Sujay?" I said, "My math says so. I've never done this before, but let's see." So, when we put it up as a proposal, he loved it, but he was always apprehensive whether this will work, simply because you're not used to seeing this. Now, when this is built, which is half built now, when it is complete, when people drive around this place and see this all the time, the next time something like this is happening with 20 floors, I'd love to do that for anybody who's willing to throw a chance my way. I would love to see, something like this come up with a higher floors or, a larger structure. So that's the exoskeleton, if you like. This is how we've reduced this whole, structure into its exoskeleton and the slabs. We are done a cast in situ slab on top of steel, this one, with your shear connectors and all of that. I'll run through some drawings here. Extensive amount of drawing making had to be done because it's unconventional. Nobody knows how to build this. So detailing. Ajit Gizre from Pune is my structural engineer, excellent chap to work with, very flexible, an architect's structural guy, if you like. Lot of detailing went in to achieve fine lines and finesse in terms of what we were trying to achieve. No welding joints had to be seen. That was a challenge. So some shots of works that have been happening here. This was a node that we came up with. So the idea was to have the nodes first position, precisely on the building, and then the struts to move in, which was not very easy because we had to engineer it fairly well using local fabricators. So once the node is in place, to put the strut in without having any splice plates or any joints was a challenge. We did that. I'll just show you a quick animation if I can. It's a 13-second animation. So this is more of the junctions, the details, and this strut being introduced between two nodes was the challenge we had to break. Now I'll just come to this. If I can quickly play this. So this is one second. So essentially, we took the strut tube and we inserted a sleeve inside and had a peg which held the sleeve in place, and then moved it onto the pre-positioned node, if you like. So it goes onto the node like that. The pin is out, and then the inner tube slides in. And there is a stopper tube at the bottom where we had pre-installed it so that the tube would be positioned in a perfect place, and then you weld across onto it. And then the cover plate comes and joins in. So this was a simple detail that was worked out. It's a very simple process if you break it down at the end of it, but for us to reach here with the fabricators, with the clients, and to deliver it and get it done was a nightmare. But thankfully, we managed to see the end of that, and this is the result that you see. So when you see this, you see a seamless joint here. When this is all plug welded and ground ends and other, and you just see the seamless flow of these pipes, and that's all. That was the main thing. So the engineering went in not seeing the cleat plates, splice plates, and all of those cluttering this one. There's another project, but I think I've run out of time. So I'll leave you with just this, and I will leave you with the last slide if you like. Just a concluding. This was an interesting slide I want to share with you. I just want to conclude with this. Of course, this is your famous San Francisco steel bridge. That's typically a fogging is an aspect that one does experience here. Why this slide is because I think the steel industry is in a state like this today. You have this steel bridge, which is reflecting the steel industry that we have today, and you're out. The other end is not quite visible yet. Now there are two ways of looking at it. Either I look at that as a fog, which is or a smoke, if you like, a cloud of smoke where we're not sure how we're going to step into this future, or that could be cloud 9. So I think people here have to now decide where we're going to take it. Is that going to be a cloud 9, or is that going to be a cloud of smoke? I think it all is in all our hands, and I think we should put our best foot forward to get there. Thank you.